right, let's talk about polynomials. You'll notice that they tell us that a polynomial is a sum of or difference of terms where each term has a variable raised to a whole number power, and that power is a non-negative integer. Okay, so first off, when we're talking about a polynomial, we're talking about one of these guys down here, all right? So each of these is a term, and you can see that if you have a sum of those two terms or a difference of those two terms, and the terms are just variables raised to whole number powers, all right? And they can have coefficients, of course, as well. So the reason that they stress to us that this needs to be a non-negative integer is, let's look at this guy for just a second. Let's say that this exponent was negative, all right? So if it was x to the negative 2, what difference would that make? Well, x to the negative 2 is 1 over x squared, right? When you have a negative exponent, it makes the variable move across the division bar. So that would make it a fraction. That would make it a rational function, right? The other thing it says is that the exponent has to be an integer. Integers are positive and negative whole numbers, right? And we've already stressed that it has to be positive. But why does this have to be a whole number? Why can't our exponent be a fraction? Well, if our exponent is a fraction, we just talked about rational exponents. Remember that if it's a fraction, that switches it over to a radical. So that would not be a polynomial either. So now we understand why we have that terminology. All right. So when you have a term like 34a to the 5th, the number that's out in front is your coefficient. So like in this case, your coefficient would be 34. If we look down here, what's the coefficient of 4x? It would be 4. So your constant is a term in the polynomial that doesn't have a variable. And so something like this 6 is a constant. Now, even though we say it doesn't have a variable with it, technically you could think of that as 6x to the 0, because x to the 0 is 1, and 6 times 1 is just 6. So that's why they say that it doesn't have a variable, or you can think of it as a variable raised to the 0 power. Now, if there's only one term, it's a monomial. If there are two terms, because remember the terms are separated by addition and subtraction signs, so two terms here, that's a binomial. So you can think like bicycle, bifocal, 2, all right? Trinomial is when you have three terms, so you can think triangle, tricycle, things that start with tri usually indicate 3. So when we're looking at a polynomial that, how many terms does this one have, by the way? This one has 3, right? So what kind of polynomial would that be? Trinomial, right? So every one of these terms has a degree, and the way we find the degree is we find the sum of the variables. So what's the exponent on x? It would be 1, right? So if we find the sum of the degrees of those variables, this would be x to the first and y to the second, so 1 plus 2 would be the degree of this term. All right, look at the next one. What's the degree of this term? 2. What's the degree of this term? Well, this is 3 and this is 1, so its degree would be 4. Then if you want to find the degree of the polynomial, the degree of this entire polynomial right here is just going to be the highest degree of its terms. So we're going to look at the degree of the terms. We had 3, 2, and 4, and since 4 is the biggest, then the degree of this polynomial would be 4. All right, look at another one. Look at this guy down here. So how many terms does it have? 3. And so that makes it what kind of a polynomial? A trinomial. So let's find the degree of each of those terms, okay? So if we're going to find the degree of each of those terms, what's the degree of this one? 1. What's the degree of this one? 5. What's the degree of this one? 3. So the degree of the polynomial would be what? It would be 5, because again, it's just going to be the largest of these 3 numbers. All right. Now, Your leading coefficient is the coefficient of the term that has that highest degree. So if we go back and we look at this guy right here, this was the term that had the highest degree, and so its coefficient, -5, would be the leading coefficient. It is not the coefficient of the term that is out in front. It's the one that has the highest power. All right, if we go back to this guy back here, what would your leading coefficient be? It would be 4, because again, this is the term with the highest degree, and so 4 would be your coefficient with that, so it's your leading coefficient. Now, the reason we call it the leading coefficient is that we typically write a polynomial in something called descending power order. That means that we write it, the first term would be the one with the highest power, and then the next term, and then the last term. So, think about when you write a quadratic, you write like 3x squared plus 2x plus 5. So you're writing it in descending power order. If it's in that order, then yes, the term that is out in front is going to be the highest one, and the number that's out in front is going to be your leading coefficient. But if it's not written in that order, like this one is not, you can't just look at the number out in front and say that's your leading coefficient. All right, so now that we understand more about polynomials, let's look at some things we can do with them. We can add them, we can subtract them, we can multiply them, all right? So when you're adding, you're just combining like terms. It's very straightforward. When you're subtracting, there's just one thing that we have to view differently. When you're subtracting, what is this subtraction sign going to do to this entire polynomial? It's like distributing a -1. So if you distribute a -1, so an understood 1 here, if you distribute a -1 through this polynomial, it is literally going to change every sign. So you'll notice for the first polynomial up here, nothing changed. It's exactly like it was. But if you look at this last one, -1 times 4x cubed become a -4x cubed. So it was positive, it became negative. -1 times -6x squared, positive 6x squared. -1 times -x, positive x. -1 times +7, -7. So again, if you compare, every one of these signs changed. It was a +4, now it's negative. It was a -6, now it's positive. It was a -x, now it's positive. It was a +7, now it's negative. So shortcut there is just to go through and change every single sign in the polynomial following a subtraction sign. Now we're back to we can combine like terms, all right? So what's a like term with -7x cubed? Again, remember, for it to be a like term, it has to have the same exponent raised to the same variable raised to the same exponent. All right, what's a like term with -7x squared? Well, it would be the +6x squared. Like term with 6x would be a +1x, and then of course our constants are like terms. So if we combine those, we've got -7 and -4, so that's going to be a -11. Remember, you combine your coefficients, but you keep your variable and your exponent exactly the same. -7x squared and +6x squared is going to give us a -1x squared. +6x and +1x are going to give us 7x, and then -2 and -7 would be -9. So that's a brief review of our adding and subtracting, all right? When we're multiplying, let's say that we're multiplying a binomial times a binomial. Remember, binomial, two terms, right? So if you're doing a binomial times a binomial, what you're going to do is you're going to take this first term x and you're going to multiply it by everything in the second set of the parentheses. So you're going to distribute the x to the x and to the 2. Then you're going to take the second term and do the same thing. You're going to take this -6 and distribute it to the x and distribute it to the 2. To help us remember that, so that we make sure we do all 4 of those multiplications, we can do something called FOIL. So FOIL just stands for first, take x times x, that's the first term in each binomial. Then outer, so the x and the 2 are on the outside. And then inner, -6 and x are on the inside. And then last, -6 times 2, because each of those is the last term in its binomial. So if we multiply that, x times x is going to give us x squared. X times 2 is going to give us 2x. -6 times x will give us -6x. And -6 times 2 will give us -12. Then do you have any like terms you can combine? Well, yeah, you could combine the positive 2 and the negative 6x. So positive 2x and negative 6x would give us negative 4x. All right, what if we have a binomial times a trinomial? So we're going to start the same way that we did a second ago. We've got to take x and we've got to distribute it to the x squared, to the 2x, and to the negative 1. Then we're going to take the negative 6 and distribute it to the x squared, to the 2x, and to the negative 1. So if we did x times x squared, that's x cubed. X times 2x is 2x squared. X times negative 1 is negative x. And then negative 6 times x squared is negative 6x squared. Negative 6 times 2x is negative 12x. And negative 6 times negative 1 is positive 6. All right, so for like terms, I don't have anything that would combine with the x cubed, but what's a like term with 2x squared? Negative 6x squared. What's a like term with negative x? Negative 12x. And then there's no other constant to combine with the 6. So if we combine our like terms, if we put the positive 2x squared and the negative 6x squared together, we're going to get negative 4x squared. Negative x and negative 12x would be negative 13x, and then our constant. So that's how we can multiply a binomial times a trinomial. Now, another type of problem that we see frequently is something that looks like this, x minus 4 squared. Now, what does x minus 4 squared really mean? It means x minus 4 times x minus 4. So it's a binomial times a binomial. And so we're going to FOIL again. We're going to do x times x is x squared. X times negative 4 is negative 4x. And negative 4 times x is negative 4x. So negative 4x and negative 4x is negative 8x. And then negative 4 times negative 4 is positive 16. The most common mistake that I see with this is if you don't write it out this way, you might actually be confused and think, okay, I'm just going to square my x, so that would be x squared, and I'm going to square my negative 4, that would be 16, but you'll notice you'll be missing this middle term altogether. So be sure that you write it out as two separate binomials and that you FOIL it. All right, here's another set of two binomials that we multiply that we see a great deal. All right, so if we were to FOIL this, we would get x times x is x squared, x times negative 3 is negative 3x, x times positive 3 is positive 3x, positive 3 times negative 3 is negative 9. So when we go to combine like terms, you can see the positive 3x and negative 3x would drop out and just leave me with x squared minus 9. That always happens when you have the exact same terms in your binomial. The only thing different is that you have one plus and one minus. That has a special name. It's called a difference of squares. And if you look at the answer, we understand why. Because you literally have two perfect squares that you're finding the difference between. So you might be more familiar with this as factoring it from this version back to the x plus 3 times x minus 3. But you also can see how when you FOIL those together, you're always going to get that difference of squares. All right, let's look at one more binomial times a trinomial. The difference here is that not everything is the same variable. Instead of just having an x as we did in the past, you'll notice that this time we've got a y as well. We're going to start the same way, where we're going to go through and we're going to take x and distribute it to every term in the trinomial, and then we're going to take 4 and distribute it to every term in the trinomial. All right, so if we do that, then we're going to have x times 3x is 3x squared, x times negative 2y is negative 2xy, x times 5 is 5x, and then 4 times 3x is 12x, 4 times negative 2y is negative 8y, and 4 times 5 is 20. All right, so not a whole lot of like terms down here. You'll notice the only thing that we have that's alike is 5x and 12x. We could combine those to be 17x, and everything else just stays the same. And again, the reason we don't have a whole lot of like terms is because we had different variables there.